Hello class, I'm back again. This is Mr. McAllen, and the purpose of this video is to do some more practice for solving log equations. And two of the problems that I have right here are two equations where you have a log and a non-log on the other side. So we're going to take advantage of what we learned in class today as far as changing these into exponential form. So for the first one, we have the natural log of x is equal to 1. And what we do is write that in exponential form and then solve it. So in this case, when we solve this equation, you rewrite it as e to the 1 equals x, and that's your answer. X has got to be equal to e, which remember e is equal to 2.718, and it's an irrational number, so that would be the answer to 33. For 35, we would write that in exponential form as well. So we'd have, I'll just write out the problem, log base 2 of 10 plus 3x equals 5. And in this case, we write 2 to the 5th is equal to 10 plus 3x. And then we're solving the equation. And that would be our answer for this logarithm. We'd of course want to check by plugging that in. So you'd have log base 2 of 25, and that would equal 5. So that checks out. Okay, and I'm back, and I have number 47, and I promised everybody in this video a little bit of crazy, so here we go. We have two logarithms on one side and nothing on the other, so we're going to compress the logarithms by using our property that addition of logs results in multiplication of what is on the interior. So I'll just rewrite this logarithm as log base 4 of x plus 3 times x minus 3 is equal to 2. And then you can rewrite that as log base 4 of x squared minus 9, because that's a difference of squares, equals 2. And now, since it's one logarithm and one number, we rewrite as an exponential form. And we solve, so we'll have x squared, 4 squared equals x squared minus 9. So now that's going to be x squared is equal to 16 plus 9. So x squared will equal 25, and x will equal plus or minus 5. Now we want to plug that into the original equation to make sure both answers work. So if you do the log of x plus 3, x minus 3, does that equal 2? Base 4 logarithm. And we plug in, if you plug in 5, you have 8 times, I want to put it in the original equation. You always have to check with the original equation just to make sure that you didn't make any mistakes along the way. So we have log base 4 of 8 plus log base 4 of 2. Does that equal 2? And when you do that, you get log base 4 of 16 is equal to 2, and that checks out. So then you would try out negative 5, and when you try out negative 5, you get log base 4 of negative 2 plus log base 4 of negative 8. But one of the properties we didn't talk about with logarithms was you can never have a negative number inside of a logarithm, so negatives are not allowed. So as a result, the only solution is x equals 5. Okay, and the last problem I want to work on is one where you have logs being subtracted from logs equaling logs on the other side. So we again have log. Now notice this is a common log problem. Okay, when you don't see a base number, you know it's a common log. So I'm going to just write it as such. Common log of x plus 8 times, oops, this is subtraction, so it would be division. X plus 1 is equal to the common log of 6. So because I have common log equal to a common log, I can just rewrite that as x plus 8 over x plus 1 is equal to 6. And now I just cross multiply, and x plus 8 is equal to 6x plus 6, and that would mean 5x is equal to 2. In this case, x is equal to 2 over 5. So in this case, you'd want to check that and plug that back into the original and make sure it worked. And I have one more problem to go over, and that's one with a coefficient. So let me find one of those to go over, and we'll resume. And here we are, we have a coefficient. So we'll rewrite on this side. Notice we have natural log of x plus 8 plus natural log of x minus 1. So that's going to just be condensed into one logarithm. And that's going to equal ln of x squared. So I should really make that natural log. And I can now drop the natural logs because they're the same on both sides. X plus 8 times x minus 1 equals x squared. This is x squared plus 8x minus 8 equals x squared. And look at this, the x squareds are nice enough to drop out of the equation. And I have 7x equals 8, or x equals 8 over 7. So hopefully watching these problems has helped you, and can help you continue your work on the solution of logarithmic equations that you have to do today in class and tomorrow. Okay? Anyway, look forward to seeing you soon. Mr. McAllen, have a good night.